Okay, this is 9.4 talking about spheres. We'll be talking about surface area of spheres and volume of spheres. One thing to keep in mind is that when we talk about a sphere, there's no difference between a lateral area and surface area. We don't talk about lateral area. Because lateral area, we typically think of a round, and then with surface area, we think about a round and the base. When it comes to a sphere, there is no base. So just something to kind of keep in mind. Okay, surface area. So we have a surface area formula that we use, and that's this: surface area equals 4 pi r squared. So if I'm given a sphere with a radius of 7, I want to be able to approximate the result of the surface area. So I use my formula of 4 pi r squared. And again, I always write that down just so I can keep it in mind. Surface area is 4 pi, my radius is 7 squared. So I end up getting 196 pi inches squared for my surface area. And then to approximate the result, you plug that into your calculator and you're going to get something like 615.752 inches squared. So that's your surface area. When we talk about volume of a sphere, it's a little bit different. So volume is how much space that sphere is taking up. And so that formula looks a little bit different. It's this formula over here. Volume is 4/3 pi r cubed. So when we talk about this, we look at the exact volume of a sphere and we have a radius of 1.5. So I know my volume is 4/3 pi r cubed. I know my radius, so I plug that in. 4/3 pi times 1.5 cubed. When I cube that, I get 3.375, and then I'm multiplying that by 4/3. So I want exact, so that means I need pi to just be tacked on. So 4.5 pi inches cubed. And again, remember, we're talking about volume, so it's cubic instead of squared like it is for area. Okay, so a spherical propane gas storage tank has a volume of 792/7 feet cubed. And let's say we're going to approximate pi to be 22/7. So find the radius of the sphere. So what I do here is I plug in, and I know my formula. So volume is 4/3 pi r cubed. I'm going to plug in everything I know. Well, I have my volume, I have pi, and I'm looking for a radius, so that's good. So I have 792/7 is equal to 4/3 times 22/7 times r cubed. Now ultimately what we want to do is get r alone. So I'm going to multiply by the reciprocal of all of that. So I'm multiplying by 7/22 and 3/4. And I'm going to do the same thing on the other side. So 7/22 and then 3/4. And so now I see that the 7's cancel here. I have that the 22, the 7, the 4, the 3, all that stuff goes away on that side. And I notice that I know that these two actually go in, so 88 actually goes in. 792, it goes in 9 times. So all I'm left with is 27 is equal to r cubed, or r equals 3. So the radius of the tank is 3 feet. Now you could have multiplied this over here. You could have gotten 88/21 and then multiply by the reciprocal of that on both sides. Either way, it doesn't matter as long as you get r cubed by itself. Okay, take a moment, read this, and see if you can figure out what we're going to need to do. Okay, so I need to find, first of all, what is my surface area? Well, I know that my total surface area is going to be the surface area of the cylinder plus the surface area of half of my sphere. Okay, So when I talk about the surface area of my cylinder, if you notice that this globe here, this half sphere, takes away this part of the base. So this part we're actually not looking at. What I need to do is I need to look at all of this and all of this down here. So I'm going to go all the way around, but we're not including the base. That base is just open. So when I'm looking at all of this, I have the surface area of my cylinder is going to be 2 pi RH, right? Because the circumference of the bottom times the height, plus I'm only going to add one base, so just pi r squared. Remember that top base is not included. So when I plug all that stuff in, surface area of my cylinder, I get 2 pi times 14 times 30 plus pi times 14 squared. So I end up getting this to be 840 pi plus 196 pi. So the surface area of my cylinder is 1036 pi feet squared. Again, we're dealing with surface area, so we're squared. Now, to deal with the surface area of my sphere, if we notice that we're doing a hemisphere, and if we think about hemisphere, that's half of a sphere, right? Instead of like a semicircle, we use a hemisphere because semisphere would sound strange. So when I do that, I need to find the surface area of my half sphere. So it's going to be half of whatever we're doing, right? And the surface area formula is 4 pi r squared. So these reduce down to 2. So I end up getting 2 pi times 14 squared. And again, I know that because this radius is exactly the same as this radius. And they're using that same circle. So I end up getting the surface area of my sphere to be 392 pi feet squared. So to get the total surface area, I just have to add these together. So my total would be 1036 pi plus 392 pi. So my total surface area would then give me 1428 pi feet squared. Or if you approximated it, you would get 4,486.194 feet squared. All right, so I have a child's hollow plastic ball and it has an inside diameter of 10 inches and is approximately 1/8 inches thick. So how many cubic inches of plastic were needed to construct the ball? Basically what we're looking at here is what is the volume of that shaded area? And we're looking at this in terms of a sphere, okay? So I need to figure out what is the volume of the whole thing, and then the part that I'm taking out would be that inside piece. So we know the diameter is 10, so that tells me that my radius has to be 5, and that's how we got this radius right here. And then if you notice that the ball is actually a little thick, it has this piece here that we're adding on to it, and that's 1/8 inches. So that's how we got this to be this thing all the way out to the edge, whereas the other one is just going right to the inside. So you need to figure out how many cubic inches, and that should also be a hint to you that we're looking for volume. So I'm going to do the volume of the larger piece, right? So all the way outside, because I know that the volume needed is equal to the volume of the larger minus the volume of the smaller. So if I find the volume of my larger, remember the formula for any volume ever, I'll write that over here, volume is equal to 4/3 pi r squared. So I have 4/3 pi, radius again is 5.125 squared. When I plug that in, oh, it's not squared, it's cubed, excuse me. Changing our formula, make sure that you double check what the formula is that you're supposed to have. Okay, so when I cube this and I figure out everything, I plug it into my calculator because we're going to use the calculator, that's fine. It says approximately. Just make sure that you store your answers and keep them. 563.859 inches cubed. When I find the volume of the smaller one, it's a little easier. 4/3 pi times my radius cubed. So again, we're just looking at the radius up to this point. And so I get that to be 523.597 inches cubed. So to figure out the volume needed, which is the blue piece, okay, we subtract them. So bigger minus smaller, 563.859 minus 523.597. And so the volume that I need, or the cubic inches that are needed, would end up being 40.260 inches cubed. And so how many cubic inches? So we would need 40.260 cubic inches to construct the ball. Okay? So take a moment, draw a picture, and see if you can come up with what the answer would be here for this, for the amount of leather needed to make this soccer ball. So this is my setup, right? So I have the bigger outside part in black, and I know that that's 0.1 inches thick. So I know that the inside diameter is 8.5. So that tells me that my radius has to be 4.25 if I'm going to cut that in half. So that tells me from the center out here, this is 4.25. And since this piece here is 0.1 inches thick, that this thing has to be 0.1 bigger than 4.25. So what I want to do here is I want to, just like the ball problem, figure out what the volume is that's there of the leather, so that black piece there. So take a moment, see if you can solve for the volume, and check back. Okay, so I knew that the volume formula was this, 4/3 pi r cubed, and I knew that the volume of the leather, which was this black ring, was the larger one of volume minus the little one. So I found that out. I found that the larger one, using my radius of 4.35, gave me this. Using my radius of 4.25, gave me this. To subtract them, gave me 23.236 inches cubed. So to construct the ball, that much leather is needed. Okay, geologists today believe that the Earth has a thin outer layer called the crust, which is, on average, about 24 kilometers thick. If the Earth's radius is about 6,370 kilometers, what percentage of the volume of the Earth is the thin crust? So this is just like the last problem, except these numbers are going to get pretty big. So I want you guys to start setting up what you would need to plug into your calculator, and then we'll come back together and figure out how to solve those numbers. Okay, so this is what I found so far. I know that my radius is 6,370, and so to find the volume of my world, so how much all of this is all in here, I used 4/3 pi times that radius, 6,370 cubed. And that's where I'm going to leave it for right now. Now the inside is 24 kilometers in, so that's leaving the crust here alone. So that new radius, if the whole radius, if I start from the center and I go all the way out to the edge, that's 6,370. But I'm actually 24 kilometers in, so I'm somewhere around there. So this is a different radius. So that's the 6,370 minus 24, or 6,346. So I know that the volume of the crust, which is the outest layer right here, is what's left over when I subtract the world and the inside. So if I get rid of all the core and the mantle and all that other stuff, then I'm just left with the crust. So I know that when I plug this into my calculator, I have to do a couple things. So what I want you to do is when you plug this into your calculator, try to leave it like this for as long as possible. So in your numerator, you're going to end up with 4/3 pi times 6370 cubed minus the inside, 4/3 pi times 6346 cubed. Remember, parentheses are important. Now, here's the where it's changed. We're looking at the percentage of the volume. So the percent of volume is going to be found by saying, okay, volume of my crust divided by the total volume of my world. So that's what we're looking at. So when I find that this is my volume of my crust, right, this is my VC. So we'll say this equals VC. The denominator is going to be your world. So when you divide, you're dividing by the volume of the world, and that's 4/3 pi times 6370 cubed. Now the important thing to keep in mind though is that these are not going to cancel. You're not going to be able to just cross these off and say that's it, because that's just the inside part. So I know these numbers are huge, but your calculator can handle them. So that means you should not be using your iPhone calculator. You should be using your scientific TI-84. Okay? So ultimately what you're going to see is that this is going to give you a decimal. It's going to give you something like 0.1126. Now we know that that's not a percentage. So to go from a fraction or a decimal to a percentage, we multiply by 100%. And that's going to give us the percent. So that tells us that it's 1.126%. So the crust is about, remember about is a key word here, 1.126% of the volume of the earth. Okay? So I know these numbers are big, but your calculator can handle them. So if you have any questions, we'll be able to answer them tomorrow in class.